be present. As I asked Rashmi Gupta and she said it's not necessary.
It's
so,
not.
Yeah.
You are our expert, so it's not necessary.
No, thank you.
Let's start now.
Okay.
Professor Rasmi.
Yes, sir.
Yeah, Ausha ma'am has joined, so just we can start now.
Yes, sir. Sir,
we still have some 4 minutes, I think so.
Okay,
so
okay.
Maybe you can start. Yeah.
Let others join.
Yes, sir.
4 minutes, sir. Okay. Just we can wait for 4 minutes. Nice.
So, okay, so I'm sharing my screen. Yeah. Yeah.
Okay, Rasmi. Then we can start.
Sir?
Okay, we can start now. It's 9 o'clock.
Okay, sir. A very good morning to all of you. On behalf of Department of Computer Science and Application, Atal Bihari Vajpayee University, Bilaspur, Chhattisgarh, I would like to present a gracious welcome to respected Professor Aparajita Ojha from PDCM, Indian Institute of Information Technology, Design and Manufacturing, Jabalpur, and Dr. Atal Chota at Department of Computer Science and Application, Atal Bihari Vajpayee University, and all the participants in 1 week faculty development program on data science and applications, data science research applications and research direction organized by Department of Computer Science and Application, Atal Bihari Vajpayee University, which is sponsored by AICT Teaching and Learning Academy. The faculty development program will introduce you to what is data science, what data scientists do, and applicability of data science across fields, and learns how data science can help you to make data-driven decisions. Data science is an interdisciplinary field that uses scientific methods, process algorithms, and systems to extract knowledge and insight from structured and unstructured data. By end of this program, learners will gain a high-level overview of data analysis and visualization tools and are prepared to discuss best practices and develop an ensuring action plan that address key discoveries. Now, moving towards, I request Dr. H.S. Hota sir, Head Department of Computer Science and Application for welcome address. Dr. H.S. Hota sir, over to you.
Thank you, Dr. Rashmi. It's my privilege to welcome Dr. Oza ma'am, the professor of computer science from IIITM Jabalpur. Participants from various parts of this country. I have seen many of them are from South and from West also. So we have almost 195 participants in this particular faculty development program. I also welcome the faculty members of my department, Professor Jitendra, and other guest faculty of the department. It's a great pleasure that we are conducting this faculty development program. And Dr. Oza ma'am is a very good teacher and as well as very good administrator. And she is a good speaker also. We have enjoyed her lecture many times during faculty development program. We have organized in association with ICT Academy, IIITM Jabalpur. So most of the faculty members of Chhattisgarh Computer Science, faculty member of the Computer Science, they are knowing Oza ma'am very well. So I hope that you will all enjoy the lecture of Oza ma'am. And definitely we are trying to conduct this particular faculty development program in organized manner. And by the end of this faculty development program, you will get some knowledge related to the data science and you'll get some research directions also. So with this, without taking much time, as we have joint inaugural function of 72 faculty development program at 11 o'clock sharp. So I request all the participants to please join the joint inaugural function at 11 o'clock. Our Honorable Vice Chancellor is one of the guests of that particular program, and AICT Chairman Dr. Sahastra Buddhe will be chairing the entire inaugural session. So with this, once again, I welcome Dr. Oza ma'am and all the participants on my own behalf and on behalf of Department of Computer Science and Application, Atal Bihari Vajpayee University, and hope that this faculty development program will be fruitful, useful for all the participants, and they will find some research direction. Thank you very much. Thank you.
Thank you, Hota sir. In continuation of the program, I would like to introduce our first eminent speaker, Professor Aparajita Oza from IIITM Jabalpur. Professor
Dr.
Oza,
Rashmi.
Yes, ma'am.
Dr. Rashmi, I think Professor Hota has already introduced me. So that's, I think, sufficient. Thank you so very much.
Yes,
we can continue. Thank you so very much.
Okay, okay, ma'am.
So participants, very good morning to all of you. I hope all of you are, I request all of you to please mute your mic so that there's no echo. Thank you so very much. So when Professor Hota, I mean, how we came into association and collaboration, Professor Hota is at Atal Bihari Vajpayee University, Bilaspur. And we at Electronics and ICT Academy at Jabalpur, at IIIT Jabalpur, keep organizing faculty development programs. We contacted Professor Hota and he readily agreed. And he actively has been actively participating as the main coordinator of many programs of Electronics and ICT Academy with the faculty members of the university. I sincerely thank you for giving me this opportunity to have a discussion on data science which is one of the very hot topic. As it is said, data is going to be the gold of the next era. In fact, it has already, you can see that data has become so important that it is more than gold to us now. And it is also said that if any other world war will be there, it will be on data and not the physical world war. So you can understand the importance of data. So I will begin with the problems that lead to analysis of data. I hope all of you are aware that United Nations has set the 17 sustainable development goals for the overall human development in the entire in the world. So if we look at no poverty, the very first goal, to zero hunger, and then good health and well-being, quality education, gender equality, clean water and sanitation. Now you can see that all these goals are so important for us for improving the human development index, right? So it also includes like climate action, as you can see on the 13th place, life below earth, life on the land, and below water, and life on the land, and so many things like justice, peace, and strong institutions, and then partnerships for the goals. Now you must be thinking on data when I'm speaking on data science, why I am giving you this specific slide to discuss and to analyze. Now, to achieve these goals, one would like to see what is the current status in each of the cases, like no poverty, zero hunger. So one would like to see the data, the present data of all the countries in the world, and in the context of India, all the states in the country. How do we look at this problem of zero hunger, for example, and what is the current status, how the trend is there? Is it possible to achieve the goal by 2030, which has been set by United Nations? So for all these analysis, we know that data is the biggest strength. I hope you agree with that. So 21st century technologies, you will find in Forbes, and data analysis tools in particular, they have biggest potential to effectively tackle the global issues. And not only do we have the largest amount of data that we had, we also have greater capacity to capture, analyze, and utilize it to create products and services to tackle fundamental human issues. These 17 sustainable development goals are actually fundamental human issues. And if we take any one of them, like no poverty or zero hunger or good health, as we have seen, the corona has taught us so many lessons. So it is the data which gives us the biggest strength, right? So let us see the data growth that has taken place. If you look at Google, Facebook, Microsoft, and Amazon store, at least 1,200 petabyte of information is available with them. And you will be surprised to know that every second, 1.7 MB of data is produced here, and the amount of data in the world was estimated to be 44 zettabyte in the dawn of 2020. So you can see how the data is growing, and it is estimated by 2025 the amount of data generated each day is expected to reach 463 exabyte globally. So by 2025, there will be 175 zettabyte of data in global data sphere. And if we look at the world spending almost 1 billion per minute, million per minute, we are spending. So this 1.7 MB of data every second is a person who is each individual, that is, he is contributing to the data generation. So especially last 2 years, last 1.5 years, have seen tremendous growth in the data analysis. Why? Because COVID-19 posed so many challenges at all levels, starting from healthcare to governance and management to education. So if I look at the healthcare, data analysis of patients, their symptoms, classification and identification, we did not have, although this novel coronavirus was there, but we had not analyzed its patterns, like how does it spread. So mining of related research work was also done for vaccine and medicine development. What kind of sequences, what kind of medicines can kill this virus? All these developments have taken place. Still, we are unable to identify that how this virus can be killed. You know that there are no medicines. So data analysis is on. If I look at the governance and management, data analysis of affected people due to COVID and other related diseases like black fungus, yellow fungus, white fungus, and sometimes some people suffer from kidney failure, liver failure. All this is happening as an after effect of COVID-19. So what are the patterns that lead to the symptoms, probably rise in the symptoms of black fungus in a person? All these things have been in discussion for a long time now. Prediction of growth with COVID cases growth and infrastructure management. You saw how oxygen crisis was there because we never expected the rise in the number of patients. Analyzing the health patterns of people after COVID, strategies and plans for the economies of all the countries in the world have really suffered a lot, and prediction of losses in industrial growth and other factors. If I look at the education research, when I'm delivering a lecture to you, I do not know any one of you, because I mean they're all blank faces. They're all I would say that small icons telling that this fellow is present. But you know that the face-to-face interaction gives you a feeling that the person is able to understand and appreciate. So that is the biggest challenge. So how effective is online teaching and learning? These questions are being discussed, analyzed, and there is no group play activity for young kids. How does it affect the children's overall health and development? There are several psychological issues, how they're affecting the people, and health of the school-going children due to long online sessions. So all these things are leading to what? Data analysis. So looking at the data science, what is data science? Data science has emerged as an effective discipline to find solutions and interpretation. Sometimes it is not possible to find solution, but at least to analyze, interpret these problems. And once you are able to interpret those problems, then there are steps for, you can say that you have climbed one step, you have moved forward one step ahead to find out a solution. So data science deals with the study of data to extract data characteristics, like what kind of data is this, meaningful patterns and relations to solve some problems using data. For example, patterns can be an increasing pattern in the COVID cases. The pattern can be a fluctuating pattern in the growth of a nation. All these things have to be found out. It is understood by people as the science behind data, just like any other science, you know. Science behind mathematical entities, science behind physical entities and physical laws, biological objects and the science behind biology, or social science. So just like any other science, you have a lot of data, which is an object. Those data objects, how do they behave, how we can characterize them, all exactly the same as we do in any other science. Well, in spite of its development for last many years now, still people say who are great data scientists say that's not very clearly defined, but it lies in the intersection of computer science, mathematics, and statistics, and the application domain. So let us take the application domain to be social science, like zero hunger is the strategy, is the ultimate objective or the goal. So that is the application domain. What is that application domain? Is a society, right? Or the country. And from that application domain, the problems will keep coming. That will lead to, that may involve, for example, humans, machines in case of industrial production, or human and machine in case of industrial production as well. And it can be biological science, or it can be medical science, as you see that the growth of coronavirus. So one can say that data science is leading to the analysis of data, using the mathematical tools like statistics, probability, linear algebra. In computer science, you can say it uses data processing, machine learning, and also many other things which are related with this. So you can see that the data science is at the center of all these disciplines: mathematics, application domain, and computer science. And it involves many different tools like statistical tools, probability, linear algebra, and machine learning tools. Of course, data processing is a part of that. Look at this chap, DJ Patil, who was the former US chief data scientist. He says that a data scientist is the unique blend of skills that can both unlock the insights of the data and can tell a fantastic story via the data, right? So the term data science began to evolve in early 2000. It was populated by this fellow DJ Patil and Jeff Hammerbecker, the leading research scientists at that time at LinkedIn and Facebook, dealing with large amount of a variety of different data. So they were collaborating with each other and expressing their concern, their strategies for managing the data and understanding the patterns of the data. DJ Patil became the first chief data scientist at the White House also during the period of President Obama. It's really a matter of pride for us. He says that I'm generally opposed to trying to define it means data science too rigorously. The important thing is how you use data to interact with the world. Okay? Study it and try to come up with new things. So, and if I quote Professor G.P. Coulter of Carnegie Mellon University, data science is the application of computational and statistical techniques to address or gain insight into some problem in the real world. So basically the problems are coming from real world, and we are looking at the data arising from the real world to analyze the pattern and to probably, if we can give a solution to a problem. So why data science? When we already had machine learning, we already had statistics and probability, why another discipline, data science? Well, data science is not machine learning, or data science is not a statistical analysis or statistical learning. Data science deals with bigger problems where you can say that the machine learning can be used to solve those problems, to provide a solution or an interpretation of those problems. Similarly, statistical analysis can help analyze the data. So, data science, we can say that there are many challenges that have come up with a great amount of uncertainty, like pandemic spread behavior or forecast, pattern prediction of like weather forecast. Weather 20 years ago, the weather was having this almost similar pattern. But now you can see that in summers, we do not have those many true summer days. And in winters, we do not have those many true winter days. From January to March, you always get, sometimes, I mean, you must have seen that this is raining. So what is happening? So weather forecast has become more difficult because of the global warming and other factors. Stock market risks, growing assistive needs in elderly population. Like in the world, we are one of the youngest countries with a very slow graph of the growth of, the aging, very slow aging graph. But we have another challenge that our young people have suffering from health issues. So aging population, what will be the assistive requirement for this? Poverty eradication, there can be many things. So data in every domain is growing with explosive rate. There are new computing and cloud technologies that enable us to effectively manage voluminous data, right? And you know that there are so many advancements in the computational power in the cloud and the cloud environment. The security in cloud environment is ensuring that we can store data in cloud. So there are a lot of data centers and you feel safe storing your data in cloud. So there are a lot of technologies, changes and developments. So now let us come to, so understanding, I hope you have understood why data science and what exactly is data science. Without a specific definition of data science, we have understood perhaps what exactly is data science. The science behind the data, right? The interpretation of patterns in the data, using the data to solve a real world problem. So if I look at the data science workflow, my dear participants, you can see that the very first question that comes to your mind is what problem I am solving. Is it the problem in food security, or it is a problem on the social network analysis? So what problem I am solving? So for this, I need to define the goal. First, you define the goal. Once you define the goal, the next thing, once you define the goal, the next thing that you would require is the information to achieve the goal. What is the current status? What could be, what are the current status of something? For example, zero hunger. So what is the status of the country? So what information do I need? So you need to collect and manage data, my dear friends. You need to collect data and manage data, right? Then after that, what happens that you need to build a model for interpretation of data. So for interpretation of data, you need to find patterns in the data that lead to some solutions, okay? I will be first extracting patterns in the data that may give us the possible solutions. Once that is done, you evaluate. So you have built a model that, okay, for example, the forecast of the people who will be undernourished by the end of 2021, 2022, 2025, how the pattern will grow or come down. All this can be understood when you build a model. Now that build a model will require mathematical tools, computer science tools, statistical tools for understanding the patterns and building a model. Once you are through, you will be evaluating your model. You will be checking its performance. So evaluate and critique the model. So the question is, does the model solve my problem? This is the question, right? So once you are happy, satisfied that, okay, this model is behaving well, it is likely that the problem will be solved. Now, in this context, I will tell you that IIT Kanpur, you must have seen this graph of IIT Kanpur for corona cases prediction. So that was a Gaussian kind of a graph they predicted. And the corona cases average 7-day average was almost like this, right? And then in the middle of April, you must have seen that the highest rise was there. Then it now is going down. And they have predicted by September, if we apply strict measures for lockdown and strict measures of keeping safe, then the graph will go like this. But if the normal case, then the graph will go like this. By September, it will be very high. So if and then, that means with the current status, the uncertainty is there, right? People may not follow the protocols. Then what will happen? If governments put a lot of restrictions, then what may happen? So what I intend to tell you is that right now, with the trends that have been shown and the predictions that have been made, the IIT Kanpur people can say that, okay, this is quite good. And therefore, they have presented results in the document before the country, right, before the countrymen. So establish that I can solve the problem. So this is what they have done. So this is one single example of telling you that how do we present. So once you are happy, you will be presenting the results. Just a minute. Just excuse me for a while. So, so you present the results then, right? And that is what we do in case of any other problem as well. So then once you establish that you can solve the problem, then the model is deployed to solve the problem in the real world. That is the general data science workflow, okay? So the first thing comes is define the goal. The question is, what problem are you solving? Let us take an example from the Sustainable Development Goals of UN, and India is also following this. For example, zero hunger. So the question is, like, what problems? In zero hunger, what problems? Zero hunger is a goal. So what problems? A problem could be like this, that with the current growth rate of food security systems and the current status of population suffering from hunger, what percent of Indian population will be out of undernutrition or undernourishment in 2030, right? If I look at, I would request you to please have a look at this. Let me just see. Can you see this global hunger index? Hello, can you see this global hunger index? Anyone can write
Yes,
on the
ma'am.
chat? Yeah, thank you so very much. Now, so this is a graphical representation of the data. See, graphical representation or data visualization. You can see alarming.
It is not visible, ma'am.
That's what I was asking, like whether it is visible or not. There is, stop sharing. Let me share again, because there is some method here that you can switch the, okay, it's just a minute, stop sharing.
Yes, ma'am, now it is.
Yeah. So screen one. Can you see now?
Yes, ma'am.
Okay, thank you. So you can see that this is a 2020 Global Hunger Index by severity. And you can see low and not included or insufficient data. So America and Greenland and all these things are not included. But let us look at this data. Low in China, Russia, and all these countries like Kazakhstan. So this is such a beautiful data visualization tool that is being used. Alarming in case of countries like Chad, Central African Republic, Congo, or South Sudan, or you can see Somalia, Yemen, and this is Madagascar, and this is Syrian Arab Republic. You can see that here naturally, because governance is almost like able to do nothing, and a lot of wars and everything. Now Mali, this, India is also included. Its score is 27.2. That is the current status. And so if we look at the graph, so where exactly India lies, the chart table, then the India lies somewhere, like you can see, so 38.937 it has been. You can see if I look at this, 2000 to 2020, 2000, 2006, 12 and 20. What is the status of India? You can see. So you can see it is 38.9, 37, 29, 27. So the decreasing pattern, right? Now, if I come back to this, can you see my slide? I seek your answer, please. Can you see my slide again? Yes, thank you.
Yes, ma'am.
Yeah, thank you so very much. So the second question related to zero hunger will be crop loss. You must have seen that so many farmers, they actually out of the problems that arise due to crop loss, they sometimes commit suicide. Why? Because they are unable to cope with the difficulty, right? So crop loss for the 5 major crops worldwide varies from 10 to 40% every year. Can you believe? And how to mitigate crop loss from plant diseases and pests to bring down, this spelling, bring it down to less than 5% in the next 10 years. So that is the question. So these can be the problems. First you define a goal, and then related problems. So many problems will be arising from this. So once you define the goal, you can plan and execute the process of data collection. So you have defined the goal, corresponding problem, and then you will begin your data collection, right? So data collection will be like, what information do you need, first of all? Example, the problem with the zero hunger can be current growth of the rate of food security systems and the current status of population suffering from hunger. What percentage of Indian population will be out of hunger in 2030? This is the question. Then you will explore probably for the last 5 years the total population in each state. Okay. You will also have a long-term data like from 2000 to 2020. And you will have a shorter time data like 2010, 2000 to 2020. you have seen that the gap was 2000, then 2006, then 2012, and then 2020, right? But then for checking the pattern of data, you would like to have year-wise data, 2015, 16, 17, 18, 19. So population suffering from food crisis in each state, density of population, district-wise, right? Like density of population suffering from this. Are there some districts with alarming numbers? Because you would like to pay attention to them, the governments would like to pay attention to them. And the major efforts and initiative taken by governments, NGOs, and other individual agencies for supply of food, employment opportunities, and all those things. So you may, these are only samples of questions that you will be raising to collect data. You can collect other data, other relevant data as well. And food supply in units per month, so many data, data you will be collecting. So initially, you have posed the problem, but you may not be exactly knowing what data characteristics or what kind of data is going to help you. So you will talk with experts, and then you will identify some data information requirement, and based on those information requirement, you will be collecting the data. Now, data collection sources can be various, right? Data comes from different sources, and for example, you will go and interview with stakeholders. You will interview the stakeholders. You will collect data from government sources. You will collect data from independent agencies. You will also make surveys of randomly selected districts based on prior information. Like if suppose there are some districts where the rates are alarming, there you will go to every house. Districts where the rates are not alarming, but you have sufficient population to understand the pattern, you will randomly select some houses, right? Some places or some people. Then publicly available data sets could be structured data also. But you will find that most of the data is unstructured. You have very little cases where you will find structured data. Like CSV may not always be structured, my dear friends, but CSV gives you a kind of some similar format of data. Data collection can be through querying an API as well, web-based API, for example. And you sometimes scrap the data from web pages. Like one of my students who's working on industrial pollution problem, she is scrapping the data from the web pages because industries are not going to give you the problem and give you the data with respect to the pollution they are creating. So the raw data that you get typically needs substantial pre-processing before you can use it, right? So what kind of pre-processing can be required? So let us look at the data collection from web-based sources. So example can be a Python request library. You can use Python request library to issue a request for the data via HTTPS, right? So this is one example, import requests. It's a request library of Python. And response is equal to request get. You are using get of HTTPS. And you will be getting the data for, say, number of people who have been vaccinated or something. So here I'm just using this kind of print status code. I'm only interested in, for example, status codes. So response dot status code. And then I'm printing the header here. So when you do that, so what will happen? You will be getting, let me, I hope you can run this code and check. how to get the status code at the header. Status code, if it is running, will running smoothly, will be 200, and headers will be the header of the web page, right? So that is one data collection source through through these kinds of requests. The common data formats that you may come across can be CSV, comma separated values, which most of you who are working in machine learning might be knowing. JSON is a JSON JavaScript object notation file and string, and it could be an XML or HTML file and string. All these things you will find in common data formats, which we use. So CSV file, what is a CSV file? It is a delimited text file in which a comma is used to separate two values, right? So you have, suppose name, you write name, Abha, comma, age 39, comma. Then the third thing, column, fourth column, you will be separating by comma. So each record, in each record, the columns that you are using are separated through commas. Right, so it can be say Abha, say Abha, and then 39, and then having shelter, yes or no, so it can be yes or no, and so on and so forth. This kind of. So each line of file is a data record, right? So for example, data record for Abha regarding hunger related data will be there. A record contains one or more fields, as you see, that are separated by commas. And a CSV file typically stores tabular data in plain text. Generally, CSV file stores tabular data in plain text, and therefore each line of the file will contain same number of fields. Okay, and it may happen because of the noise or because of something, the file that you get may have some incomplete entries as well. So let me give you an example. Like in Zoom platform, suppose I have to record and that happens with WebEx also, my dear participants. So there are so many participants I have put intentionally, I've removed their names. So these participants voice is not coming. Somebody says, voice coming or not? Voice is not audible. Am I audible?
Yes, ma'am. Yes, ma'am.
Okay. So Indrani ji, you please check your speaker. All right. So let's see what's the join time, right? I conducted a workshop on healthcare innovations in COVID outbreak. So 26th, this was there. So joining time was 15:52, 16:53, 62 minutes, then 2:46, 2:45, and you can see that these are the timings, right? So you can see that some of the records have been misplaced, like this should be here. And so this kind of noise can be there. That is what I wanted to tell you. So then comes JSON file. What is a JSON file? JSON stands for JavaScript Object Notation, and it is a lightweight data interchange format, very lightweight, and it is easy for humans to read and write, and easy for machines to also parse and generate. So it is easy, like JSON object is easy. And it is built on two structures. One is the collection of name value pairs like you do in Python, the dictionary. In various languages, this is realized in an object, record, struct, dictionary, hash value, keyed list, or associated array. And it can be an ordered list of values. In most languages, this can be called like array, vector. And in different languages, it's called array, vector, list, or sequence. So it can be either in this form of key value pair, or it can be an ordered list of values. Example of JSON string like name, is the key and the Mohan is value, age key 32 value, bike key Honda value, right? So like this. And it's very interesting that JSON is language independent. So let us consider a message using JSON. You have to write a message using JSON. So title, example, glossary, glossary division, glossary list. All this, you can see that it is easy for us to understand, like ID key value pair is given here. You can see it is the key value pair. Oh, I forgot that this I've taken from a website. As a website address is given at the end. Similarly, if you want to have the same thing, same message using JSON and same message using HTML, XML, this is the difference. Message is the same, but difference you can see, right? So I wanted to tell you that these are different types, like first of all, data collection. What are the various sources of data collection? Once you have collected data and you're happy that, okay, you're satisfied that, okay, the data that was required is perfectly fine. Slide is static. Somebody is saying slide is static. Is data pre-processing not seen, my dear friends? Can you see data pre-processing?
Yes, ma'am.
Only heading is visible.
Yeah, only heading, I agree.
Visible,
Fine,
Yes,
so I'm going ahead. Yeah,
Yes.
thank you. So data pre-processing, then once you have collected data, you would like to pre-process that. Real world data generally is unstructured, may contain noise, missing values, a format which cannot be directly used for processing, right? So preparing the data for your analysis, whether it is a statistical analysis or it is any other kind of mathematical or machine learning analysis, based analysis, you need to prepare the data for this. So preparing the data preparation means what? Data pre-processing and data conditioning, right? So data pre-processing is used to clean the data, make it suitable for analysis, and also known as data. Also, sometimes it is known as data conditioning. And some people use data conditioning only when you use normalization, scaling. That is also known as data conditioning. So in data science, learning about the data is a critical aspect, as you can see. Let us take an example of a data collection. For a survey, suppose you employ 10 persons as data collection agents. पता नहीं कुछ लोग बार बार कह रहे हैं no audio, but I think my audio and everything is coming. My request to all of you is to please check at your end.
Yes, ma'am. You are audible, ma'am.
So Narendra ji, I mean, perhaps it is something at your end. Please check your speaker or. Thank you so very much. So for example, let us take this example, right? You are sending 10 people as data collection agents to collect data from different locations in a city for estimation of a hunger index of the city, right? Thank you so very much. So then you may also have a different number of columns or fields. Let us take this: name, age, source of income, number of members in the family, does she have a ration card, has shelter or is homeless, does he get enough food 3 times a day, and so on. My dear friends, those who are interested in data science, I invite you, let us make it a goal to at least look at the hunger, like zero hunger, right? Think of the day when for the almost day you had nothing to eat, any previous day, mainly because of work or because of any other thing that you hardly could get time to eat, how do you feel at the end of the day? So, my dear friends, it is the right time all of us combine our efforts to become data scientists by first collecting the data, reprocessing the data, making surveys, and let us think that can we solve this problem? Can we provide a solution to the government that if these strategies are followed, then probably we'll be able to have zero hunger by the end of 2030, right? Or at least a very little hunger people who are suffering from undernutrition. So, so now the response can be collected from different people in different, can be collected by different people in different format. Even if you train them, see, to err is human. So even if you train them to collect data in specific format, the first person goes to village A, second person goes to village B, third village C, and he or she are making entries in the data, and that can be different. So variations in data collections, let's see, name, age, source of income, number of members in the family. So you can see how it is changing. Say name Babulal, age 45, none, ration card no, shelter no, food no. Food 3 times, we take on an average 3 times. The second person, this is agent number 1. The agent number 2 will be collecting data like this. 32, income source was nil, but he wrote dash dash. Ration card, 1, so he's using 1 and 0 as the symbol. 1 means yes, no means 0. 1 means yes, no means no. 0 means no. Shelter, so he writes no shelter, so this like this. Put 3 times. This fellow is using yes or no, binary values. This value is counting the number of times the person eats. And similarly this. So what I intend to say that in spite of, now you must be saying that there are so many software tools, it may contain some missing values or variations in columns where the manual user input is required. So numerous data preparation tools are available. You can check out some of these. For example, I would like you to check that. This one. Can you see this solution review data integration slide?
Yes, ma'am.
Okay. So they are telling the 10 best data preparation tools and softwares for 2021. So one was Altair. This is this is not a free source. And then the second one, Alteryx. The third one, Cambridge Semantics, and so on and so forth. They will give you these, and so you can get very interesting information from here, right? So now I come to back to the slide. I hope you can see the slide. You will also find those who are working in machine learning field. You will find that pre-processing data in scikit, like sklearn library, you can see this. Can you see the 6.3 pre-processing data?
Yes, ma'am.
Thank you so much. So on the left side, you can see this pre-processing data, standardization or mean removal and variance scaling, nonlinear transformation, normalization, encoding categorical features, discretization, imputation of missing values, general polynomial features, custom transformers. These are all data pre-processing tools, my dear friends. Coming back to this, so you can find these are available. Now, my part 1 is complete. I would like to know if you have any questions. I give a 2 minutes break to you so that, because it is all descriptive, you know. So, and I know that human, they have how their receptive fields work with respect to constant speaking by somebody. So I'm giving you 2 minutes break. Think about the questions. I'll come back. Just 2 minutes break.
Yes, ma'am.
Yes, participants, you can raise your question through the chat box also. And we can put it in front of Dr. Oja. If you are not able to speak, you can put your question in the chat box. There is one question.
Yeah, so there is a question on how data set is collected as image data by Dr. Salina. So, madam, image data, what, like the, again, I will ask you, what is your question or what is your problem? If your problem is, say, smart agriculture and pest disease control, you will go and take images either through mobile, or you will be making use of the satellite data, which is already coming through various sources for looking at the images at large scale, or you will be using a drone-based application and to capture the data from the fields. So, image data taken from mobile. You have beautiful like mobiles which are having say 20, 30, 40 megapixel and 80 megapixel kind of images. So you have very large images. Drone camera will have limited size of images, like for example, 512 cross 512. Satellite data will have all these will be having colored images, but satellite data may have other images as well, like it can be infrared sensor, it can be different kind of sensor that can be used. So it may have say, various channels in the data. So you collect images, they will be of different sizes. So how will you use them for your analysis? You will make them of same size, right? That is one method of data conditioning or data pre-processing. Is that clear to you, ma'am? The next question is, how can we identify which pre-processing technique suits for which kind of data set? Well, Jyoti ma'am, you will be able to identify once you choose the problem. Now, pre-processing means what? Removing noise. I mean, you would like to normalize them. So it is not which pre-processing method. It will be depending upon the data that you have. Some pre-processing methods are standard in machine learning applications, right? Like scaling your data, normalizing your data. These are standard methods. But you may also find looking at the data visualization by first see, it is said that if you cannot understand what is data telling you, you cannot make your machine learn what the data is telling you, right? So unless you visualize yourself the data and the pattern to some extent, you will not be able to solve the problem effectively, right? So you cannot be like blindly giving the problem to you. First, you will visualize the data, understand, and then only you will be able to give it to someone else. So for data pre-processing, what we do, we generally see the patterns and then we see that, okay, some of the values are missing. You will be dropping those entries or you will be augmenting some of the data. So all this data pre-processing, it depends on the problem that you choose. I want to analyze COVID status based on image source like CT scan. COVID status based on image source like CT scan. CT scan of a person, yeah. So you will, in this case, you will have to use either the statistical analysis or you will have to use the image processing method, or you may be required to use machine learning depending on how many images do you have, right? So based on image source like CT scan. So only when you have CT scan data available, as an ordinary man, as an ordinary people, we cannot have that data. You will have to collaborate with a doctor or a pathological center, tell your problem that this is what you want to do, and they may give you the access under certain restrictions, because you know that these pathology centers or medical colleges or medical hospitals, they also have to satisfy the ethics to retain the privacy, to keep the privacy of the patient. So it is not that easy. Our free data preparation, but let me tell you that sites like Kaggle provide you a lot of free data for your analysis. Then the question is, how can we identify? I want to avoid analyze. Then are the free data preparation tools effective independent research? Yes, they're very effective. Darshan Sharma ji, they are very, Darshana or Darshan Sharma, they are very effective. We are actually all of us are basing our this on open source data, because open source technology, open source is lot of has a lot of potential to grow, because open source the tools also provide you the code so that you can modify the code as per your requirement. You can also analyze the code so that there are no bugs. So debugging is also done. So they are very good.
Yes.
Give,
Hello.
yeah.
Madam, I want to ask, I want to get patient data from a streaming data site. Is it possible to get that? The records one by one, I want to fetch. Do you have
So
any idea about that?
patient, see, that's what I'm saying, that patient's data, there are ethical issues with respect to patient data. And only when you have contacted and you have collaborations with some such
Hospitals.
medical hospitals or pathology centers, then only you can get data from there.
Yeah. Okay.
Right. Can you get an idea? But there are, Ganeshji, there are some data which are available on the public domain.
Yeah, I want to know that only. Like Kaggle, you were saying, if there is some test data which is available, like patient disease data.
So what kind of data you want?
Patient name, its age, education, and sensitive disease attribute I want into that.
No, I mean, what is the problem? Like, what problem are you solving?
I
So
want to
Kaggle is one site. Then you can find out some university sites also which provide free data, like UCI machine learning repository. They give you a lot of patients data.
I'm working in privacy preservation and in health sector. Hospitals can publish their data, patient data, using the privacy preserving methods. So that data can be available for agencies for statistics purpose. How the spread of particular disease is there, how relief can
So
be.
there you don't require the name.
Yeah,
Especially the identity, Aadhaar number, these things are not required, because the problem is different. Problem is the spread of this. So it can be anonymous, but the rest of the data can be obtained. Yes. There are certain sites, I have not worked on this problem, so I cannot tell you exactly sites. There are certain sites which provide you.
Okay, thank you.
Okay, what is the best suitable way to collect data with minimized noises? To automate that tool, you have to like automation. Like you are sending 10 people to collect the data, you give them all a mobile app with their mobiles, so that there are only these many values, right? Yes or no, dash, not dash, all these things. So automation can be better. What is the best way to learn data science for an EC background? My dear friend, there is no background that is required for like EC or CSC. Don't think that CSC is having an upper hand than an EC or a mechanical person. For data scientists, you need to develop certain skills which are pure mathematics like linear algebra, and then statistics like statistical probability. And then in machine learning, nowadays electronics and communication people also do a lot of machine learning. So you have to learn the basics of machine learning and then take up a problem. I suggest you take up a problem. For example, you can take any problem with respect to the monitoring of a patient through EMG data, right? So that is this monitoring will help you understand the data that is coming from the EMG data that is coming from the body. And then you can apply your mathematical knowledge, statistical knowledge, or machine learning knowledge, because it is not very clearly understood that what exactly, which kind of algorithm will suit to solve this problem, right? Okay. Is there good data for cursive handwriting recognition? Yes, lot of data is there for cursive handwriting recognition. Lot of data is there. These types of data are available in sites like for cursive. For handwritten sketches, we have data for like we have MNIST data, we have CIFAR data, we have a lot of data is available. You please just check that. And now I start sharing my slides. Thank you so much for your questions. Give me a minute. I hope you can see my screen.
Yes, ma'am.
So now we come to data visualization. As I told you that somebody was asking that which pre-processing method is the best. It depends on the data and the problem. Okay. So we need to first visualize the data, understand what exactly is there in the data. Instead of just giving it blindly to the algorithm, it is first suggested that we visualize the data ourselves and explore the data. For example, this iris data set, most of you who have done machine learning algorithms you have used must have used that these are 150 samples of iris flower of 3-4 categories, I think 4 different categories. And out of those 150 samples, they have sepal length, sepal width, petal length, and petal width. These are the dimensions. So let us look at the sepal length and sepal width for this, and for 3 types. I think here it is 3 types of flowers. So before you make an analysis model for the data captured, it is important to visualize and explore the data and understand its pattern, because if you cannot understand the pattern, you cannot make machine learn understand the pattern, right? So data visualization tools provide an easy way to understand trends, outliers, and patterns in the data. Like in the previous case, you can say that these are the outliers, or these are the outliers. You can say like these are the outliers. You can say that, right? So that helps in data cleaning, Data visualization will help you in data cleaning, exploring the structure of the data, identifying some unusual groups. Like, let us look at the social network analysis. You must have seen that the government is keeps on monitoring the flow of information among different people, and terrorists are also using the information technology tools to communicate messages. So if there is some unusual activity or a lot of information sharing within a small group, that could be some good exercise going on or some good activity going on, or it can be due to some unusual bad activity. All these things have to be understood. Identifying unusual groups, trends and clusters, spotting local patterns, as I told you, like if the same activity you see it is in Jammu Kashmir in the border area, you will have to look at the local pattern. Evaluating modeling output, presenting results, all these things are required. So some frequently used tools for data science projects, one of them is Tableau, very interactive tool. It is used for data visualization and analysis in industry. It provides a real-time collaboration. I'm sorry, somebody is shouting, so I hope you don't have any noise. Data Wrapper is another user-friendly app for data scientists. It is generally used for, say, non-technical people as well. For example, like news media, they use it. For machine learning researchers and developers, TensorBoard is a useful visualization tool. TensorBoard. Oh, I'm sorry. This spelling, please correct. This is TensorBoard. Right? You can see it here on this website. Information on some open source data visualization tool also, you can see these. This is available here. Then comes the, so I don't think the data analysis is the main part. Data collection, data pre-processing, data visualization and exploration, all these are important parts of your data science project. Then comes data analysis or building a model. So this can be in a statistical model like hypothesis testing. So hypothesis can be, for example, with the current trend, the number of malnutrition people will go down to, say, only 3% by the end of 2030. Suppose this is what you want to say as the null hypothesis. So against this null hypothesis, you have H0 and H1. Right? H1 will be negating this hypothesis. So we do analyze the mean between two populations. The population related to people who will be have suffering from hunger. So you look at the two populations, and if there is a difference, that means the other hypothesis, H1 hypothesis, is successful. But then if there are more than two populations, so in that case, you use analysis of variance, like a generalization of hypothesis testing for multiple populations. It can be, in case of multiple population, for example, people who are suffering from hunger, people who are having, people who are not having any means to earn, people who are, so you can have 2-3 different types of people, and people who are shelterless or homeless. There can be many populations. machine learning models, you must have seen clustering is very much, very frequently used. Regression is used for data analysis. Classification is used. All these kinds of machine learning tools are available. So what are the data analysis challenge? From the gigantic size data that is available, find a key pattern that indicates a situational change, right? So you saw that the data was available of different viruses. A small pattern that changed the entire situation was this virus, coronavirus, right? So could be a single event or a sequence of events. The key pattern could be an earlier observed one, or could also be a new pattern. Like the biggest example is this new mutant of coronavirus this year. Last year was different. This year it has been different in India. Predict the next event based on the current patterns. Identify relevant fragments from the multitude of data sources. Data source may come from, say, cities, from rural areas, from metros. So relevant data fragments from a multitude of data sources, and find the few packets in a billion of packets flowing through the different networks that carry a virus or a malware, for example, right? So data analysis and interpretation are very important things. So solving problems with high dimensional data, with a very high degree of uncertainty in data, that requires some non-conventional approaches. Apart from mathematics and traditional statistical approaches, machine learning has proved to be very powerful to analyze the data and find out the solutions for real-world problems. So what is machine learning? Give me a moment. Yeah, thank you. So what is machine learning? All of you must be knowing that it's a field of computer science where the algorithms are supposed to automatically learn without being explicitly programmed, right? So you create a model which automatically learns from the data, learning from experience on data to make certain predictions. So what happens, you generally in machine learning, what you have a training data. A training data can be, for example, training of 5,000 cases of COVID x-rays, of COVID, non-COVID, and normal x-rays. So pneumonia due to COVID, pneumonia not due to COVID, and normal x-rays. So you will be giving this data, it will go to the machine learning algorithm. Algorithm will try to understand and fetch the patterns of the data, and it will make prediction that the fellow is COVID affected, pneumonia due to not COVID affected, or it is normal. Right, so COVID affected, not COVID affected, and it is normal. So these cases, it will be making prediction from these 5,000 examples. And if it is able to make, say, 60% right predictions, we say that, okay, it has learned some pattern, but not really well. You will be again presenting this 5,000 example to this. It will again be checking its mistakes and perhaps will next time will give you 75%. And this process keeps on. Like you keep on giving the same data again and again. Like you tell your students sometimes the same numerical problems with a slight variation or same numerical problem exactly. And so it learns with, say, 98% accuracy. Once suppose you get good accuracy, you deploy the model to the real world. So this is a trained model which is deployed in the real world. Then comes a new case of X-ray, and it makes prediction whether this X-ray is of a COVID affected person or not COVID affected person. This is how machine learning algorithms work. So what is training and testing? From the universal set of people, I take some cases, say 5,000 examples, take samples from the data. These 5,000 examples are presented. In fact, there is something which is also known as validation. So out of these 5,000 examples, you will keep some, say some 500 examples for validation. You will not show during training. So you take some 4,500 samples, and then you can say COVID affected, not COVID affected. Take samples from the data. This sample you will be providing to machine learning algorithm. And as I told you that these samples will be again and again presented and will be going again and again through this process. And finally, the machine learning algorithm will learn to accurately predict the pattern and make predictions. So then it will make prediction. All right. So once it is done, machine learning algorithm training is over. I will be providing the new data from the real world, and then it will be making predictions. So you can see here the samples are coming which are COVID and non-COVID. The machine learning algorithm is making some mistakes, like humans also err. Error can be, to err is human. Similarly, machine learning algorithms may also make errors. So the training is the process of making the system able to learn. So there are three broad categories of learning. One is supervised learning, unsupervised learning, reinforcement learning. In supervised learning, what happens? You have data with labels, right? For example, you have 5,000 examples of COVID and non-COVID affected. So doctor has already identified of these 5,000 examples that these are COVID affected, these are not COVID affected X-rays. So those labels are already put on the data. That is known as data with label. Data without label. Suppose the doctor, you know that in those cases, those days, doctors were very few as compared to the number of patients, especially in April. Lot of X-rays are kept. And then you will ask the technician who may not be knowing anything about that, whether the pneumonia is due to COVID, not COVID, whatever. So he will be making some prediction based on his understanding. So that is what is known as unsupervised learning, right? Because there's no label. And the third is states and actions, which is based on the present state and the observation of the environment. Some decision is taken, and that decision can be a wrong decision or a right decision based on which I get the penalty or a reward. So this kind of learning is known as reinforcement learning. I will not go into details of these. I only wanted to give you a glimpse of what learning tools are, machine learning tools are used in data science to analyze the data and to make a model. There's something called semi-supervised learning. What is this? Semi-supervised learning algorithms are those algorithms which work on data with labels with a very small number of data. Rest of the data is all unlabeled, okay? So supervised learning, you can see the data can be text data, documents, it can be images, it can be sound. So with labels, the data is provided. For each, say, document, the document can be classified or non-classified, right? For example. So that label will be attached to that. From that data, some feature vectors are generated. Like if suppose the data is, say, 500 dimensional data, I will be taking some relevant 25 features from the data. It can be statistical feature, it can be geometrical feature, it can be shape feature, whatever type of feature, depending upon the data that has. Frequency, term frequency in case of documents and text. So all these features will be taken out. and this along with the label will be sent to the machine learning algorithm. It learns, and then after the model is created with great accuracy and great precision, then it is deployed and the new text comes, right? That is what is supervised learning. Now check here. I seek your attention here. Now, unsupervised learning, there's no label. Here it was labeled, here it is no label, right? That is what happens. Okay, so you have created what? You have collected data, you have pre-processed data, you have visualized data, you have selected a specific machine learning or statistical model for your analysis, okay? Now here is the catch. What kind of model do I choose? Is it going to really help me with solving my problem? So that is the biggest area, which is, you can say it's a dark area. You will have to apply different methods. You have to seek the information from previous literature review, and then only you can think of making a model. Then comes model evaluation using certain performance measures, like, for example, in a machine learning, we use accuracy, right? Precision, recall, F1 score, or measure the error of approximation using mean square error or mean absolute error. These are certain measures that we take, right? And that we do on new samples, not on already trained samples. If you do that, that's not a good evaluation. Evaluation has to be done on a bunch of examples, which are new examples, not shown to the model before, okay? So there are data visualization tools that are used again, to understand the present model's performance. You must have seen the accuracy graph, the precision graph, the recall graph, F1 score. May I ask you a question? Is accuracy a good method of performance evaluation? And when it is good, when it is not good? Can somebody answer? You please write on the chat box your answers. So recall is also known as sensitivity sometimes, right? No, accuracy, when the accuracy is not a good method of checking the evaluation. That is my question. Yeah, only for balanced data set. Very good, Mr. Dr. Behar, Nishan Behar. Only for balanced data set, accuracy turns out to be good. For like unbalanced data sets, you would not like to have this. You would more rely on precision or F1 score, which gives you these things. So once the model's performance is acceptable, it can be deployed to solve the real world problem. So the ultimate question is, does the model solve your problem? In spite of all these things, model's performance, what is happening these days, that we are finding that the current AI tools are not that transparent. Like reinforcement learning is a little more transparent. Imitation learning is another method that is coming up very nicely, is a good alternative to reinforcement learning. That is also quite, as a more transparent. But the current methods of machine learning, they give you the answer, but why a model has failed to correctly identify a COVID case or not correctly identify a COVID case, this why and how is not known. So what happens that the model may be doing, sometimes you may be getting 100% accuracy of your model or 99.9% accuracy. Deploy it in the real world. You will find that that accuracy is never achieved. Like one of my students is working on one such problem. When she deployed it on the data sets, which are like well-known public data sets with 50, 60, 70,000 images, it is working with 99.7% accuracy. Balanced data set, everything is good. When she went to the field and checked, it was only giving some 50% accuracy. So you can understand that it is not always the model that performs well in laboratory or in your computer can also perform equally well in real world situation. That is the biggest issue right now. There are several models that have been proposed. They remain in the literature, in the research papers, dumped, but you don't have a perfect solution for the same problem, for some problem. So data science challenges, like one of the biggest challenge as a data scientist is applying the domain expertise to solve a problem. As I told you, that you may be very good in statistics and probability. You may be very good in machine learning algorithms. You may be having very good theoretical background, and you must have done quite a few good, you must have written quite a few good research papers deriving methods. But when it comes to solving, we have a plethora of algorithms and techniques to get the value from data, but we need solutions to help us apply that to the applications. So solving problems and predicting outcomes using a sophisticated model requires both an understanding of the capabilities, tools and techniques behind data science, and the ability to get out from behind the keyboard and ask questions to inform the data process. This is what Michael Schmidt, data scientist, founder of Newtonian, says, and I completely agree with that. So what are the challenges? Like causality, finding out causes, like what could be the cause for this predicted value of data? So simple methods of learning, mappings on like what you do, for example, in machine learning, you are mapping, given X input, you are mapping it to a Y, a label, right? Maybe. So you're looking for a mapping on observational data that often fails to capture the causal effect of interest. What is the cause? That is something not clear. Then sequential learning, learning from mistakes in the past. We did not learn from the mistakes in the past. Coronavirus 2020 was very dangerous. And this time we became so careless that we did not learn from the past. So learning from mistakes in the past is a very good thing. And that generally we do not associate the current problem with the previous solutions and previous mistakes that we made. Then there are complex dynamic theories, like many machine learning AI methods, while often having very good predictive performance, mostly suffer in transparency and interpretational ease. So this fellow, who is Maurice Captain from Tilburg University, says that we need to actively develop ways in which we can bridge the gap between the theory and the data. You have good mathematical theory. Like I must tell you, as a mathematics student, we were used to be very happy that existence and uniqueness theorem. It says that under these conditions, if some set is convex, there will exist a unique solution to this problem of differential equation. Okay, good. Where is that? How to find out? I have only proved that there exists a unique solution. Well, that theory is important to find a solution, because unless that theory says that there exists a solution, if I'm just finding out solution without existence, it will be an infinite loop. So that theory is important, but the methods to find out that solution are also important. So in summary, I would say that the data science has evolved as a separate branch of science due to explosive data growth. Its exploration and analysis of finding out solution to real world problems has given many solutions, of course. And that is where people found that data science can be considered as a different discipline. So data science falls at the cross section of mathematics, statistics, probability, and linear algebra, computational science, and application domain from where the data is generated. Machine learning has evolved as an effective stream of computer science to help data scientists analyze the data. And especially the deep learning, the new era of machine learning, where deep learning has dominated the scene, is proved to be very useful. Machine learning can be supervised, unsupervised, semi-supervised, or it can be reinforcement learning. There are so many powerful machine learning methods that have evolved over a period of 3-4 decades. But data science problems are different than the machine learning problem or typical statistical learning problem. Data science is looking for from the application is trying to solve a bigger problem, right? Or a problem. Whereas the machine learning, you only are interested in, okay, given this data, am I interested? How effectively can I build a solution for finding a mapping between X and Y, for example? So that is a more specific thing. So, my dear friends, this book by EMC Educational Services, you can find this book very useful. I hope you can see that. This is a second book by An Introduction to Statistical Learning. Lecture notes by Professor Zico Coulter. Yes, this is a very good resource. Carnegie Mellon University on Practical Data Science. I've taken much of my stuff from here. Hard Problems in Data Science, an article by Arjun Herring, where from I took this last content of the last but one slide. So before I conclude, I must say that you should all be safe and healthy, and you should live happily with your near and dear ones. Please follow the protocols to keep you safe and healthy. And we must together work together to defy all the predictions made based on data science that the third world will be more severe. That can happen if only we trust ourselves and accordingly act. That is all I have to say. And now I am open for questions. I think we have some time for questions. Yes. I concluded quickly because I thought that there is going to be a common what is called inauguration session. So I thought of concluding quickly. Questions if you have.
Common inaugural function, madam.
Yeah, it's a common inaugural. So I think all of you must be present.
72 FDPs are going to start today.
Yeah, that's a new record that AICT is making. Yeah.
Yeah, AICT has it's a new record.
Any questions, please?
RK Soni sir he's also from Jabalpur, ma'am.
I know him very well. Yeah.
And he was here in the Central University. We have worked together with RK Soni in Guru Ghasidas Central University.
He was in Bilaspur. Yes, he was.
He was in Guru Ghasidas. I was also there at that time.
Achha, you were there? Okay.
Yeah, I have worked there for 10 years. Then I have switched in 2014 in Atal Bihari Vajpayee University.
Achha. Oh my God. This I did not know. So any questions you have?
Yeah.
Slides slides I will share with Professor Hota and Rashmi Madam. I'm going to share, don't worry. Slides I'm going to share. Any questions if you have? other than this also, I mean, it's not data science only. You can ask any questions if you have. Well, I thought there'll be many questions, and so I kept it short, brief. I would have otherwise gone to more on machine learning and other tools, statistical learning tools. If you have no questions, then I wish you very good luck. Dr. Vikas Gupta is saying that there are, tell something about tools used. So I have like we generally use the TensorFlow data pre-processing tools, data visualization tools, and a scikit library because we work on machine learning. I don't work on statistical analysis. I work on machine learning. So we use TensorFlow, like let me tell you TensorBoard. So if you use this TensorBoard, you can see this TensorBoard because we are mostly using TensorFlow library. So you can see that here on the left, on the right side, different types of tools can be used to visualize the data and present the results. So this is one of the basic data visualization tool, TensorFlow visualization toolkit. And then I told you about another toolbox, that is scikit learning library. So that is also very much used by people, right? Tableau tool, madam, Dr. Selina, I have not used. So, but you will find that Tableau is being used by many industries because of its ease. It's a like visualization is so interactive that you will prefer to use it. But then we have not used it. Tableau is not. I mean. That is not what I've used. So I'm sorry, I have very limited knowledge about that. What about, can we use either Tableau or data wrapper tools? So what is your problem? Tell me, what is your problem? It's better to use open source tools, right? Use open source tools. I've given you the link. Depends upon what is your problem. See, in academic domain, we promote open source. So there are 7-8 open source tools which you use. And if you are a machine learning expert, you can, a machine learning student or machine learning expert, you can use this TensorFlow or other tools of which are used in Python programming. You can use any one of them. Like for plotting, you have another tool for Python, right? Image plotting. All these things are available. So why, I mean, I don't know, for presentation of graphic presentation, definitely these licensed tools are very, very important. And then there for SPSS is also another visualization tools, right? So there are so many questions like web scraping. Web scraping, you can use like suppose you want header or you want anything else. So I have probably in one of the future lectures, because this is on data science, So somebody might be specifically dealing with data capturing or data collection. So they will probably give you more details on web scraping. In 10 minutes time, it is not possible to do that. I will share my lecture slides with Professor Hota and Dr. Rashmi. And that is all from my side. If you have any questions, please feel free. What are the opportunities for non-computer science and data science? You have plenty of opportunities, Mr. Preetham Pandurang, because data science is understanding the data and getting insight. So if you are a mechanical engineer, you will be getting data from vibrations of machines to understand what is going to be the aging pattern of a particular machine. If you are from social science, you will be getting the, as I told you, zero hunger is one case of social science. If you are from any other science background, even if you are from arts background, you can make meaningful contribution by designing properly the questionnaire and the data collection methods so that data processing becomes easy and data analyzing the data becomes easy. So with this, I conclude my session, stop sharing.
Yeah, Professor Rasmi, just vote of thanks.
Yes, sir. Yes, sir. Thank you so much, ma'am, for giving such a nice and knowledgeable lecture. And all the participants have definitely benefited from your informative lecture. We are very grateful to you for giving your precious time and being agreed to be a resource person in our faculty development program. Thank you so much, ma'am. Now, I request
Thank
all
you.
the
I indeed
participants.
enjoyed.
Yes, ma'am.
Enjoyed the session. Thank you.
Yes, ma'am. Thank you, ma'am. I request all the participants to attend the joint inaugural function using the YouTube link shared on the group, and we will meet at 1 p.m. for the second session. Thank you, all the participants.